right, we're ready to work through our first full hypothesis test. This is a problem that you've already started reading about, so this will sound really familiar. The board of a major credit card company requires that the mean wait time for customers for service calls is 3 minutes. They want to determine if there is sufficient evidence to say the mean wait time is longer than 3 minutes with a significance level of alpha equals 0.05. To make sure that the mean wait time is not exceeding the requirement, an assignment manager tracks the wait times of 45 randomly selected calls. The mean wait time was calculated to be 3.4 minutes. You may assume the population standard deviation is 1.45 minutes. Help the board determine if there is sufficient evidence to say that the mean wait time is longer than 3 minutes with a significance level of alpha equals 0.05 using a 1 mean z test. So we had a 1 mean z interval and a 1 mean z test. So anything that's an interval is going to use the panic method, and anything that's a test is going to go through the phantoms method. So our P here, we're going to test the claim mean wait time more than 3 minutes. So again, this doesn't have to be a complete sentence. It doesn't need to be super technical. Just jotting down enough words so that you don't have to reread the whole story to write your conclusion. Our hypotheses, our null hypothesis is that mu is equal to 3 minutes. And our alternative is that mu is greater than 3 minutes. So that makes this a right tail test. We have 3 assumptions and conditions to check. Simple random sample, so random is stated in the problem. Our sample size here is 45, so 45 is bigger than 30, which causes the central limit theorem to kick in. So we do have large, and then our population standard deviation is sigma is equal to 1.45. The name of this is a 1 mean z test. And then our test statistic, we're going to plug in our x bar minus our mu. So the 3.4 came from our sample, and that 3 is actually our null hypothesis. And then the 1.45 and the 45 were stated in the problem. All right, I'm going to switch over to Excel so I can show you how to put this into the calculator in Excel and how to get that p-value, and then we'll come back over here. All right, so here we are back in the Excel calculator spreadsheet that I built you. And so those tabs along the bottom are going to help you keep track of where you were at. So that 1 mean z interval, which was chapter 16, this is the one that we were on. Oops, we switch over here. This is the one we were on. And now we're going to go to the 1 mean z test. So the name is there as well as the chapter to kind of help keep those straight. So this is what it's going to look like, and we're going to start by putting in x bar. So our x bar, our average from our sample was 3.4. Our null hypothesis was 3. Our standard deviation was 1.45, and our sample size was 45. So I put those in, and so now you can see where I get that calculation of a test statistic of z equals 1.85. And then our alternative hypothesis was that it was greater than 3 minutes. So greater than is going to be a right tail test. And so what we want is this number here, 0.032. So I usually use 3 decimal places for these, so I have enough to compare to my alpha. So 0.032 is what I'm going to take back with me. And I'll see you back over in the PowerPoint in just a second. Okay, so here we are back on the PowerPoint. So there's my z equals 185 that I got from the spreadsheet. And then my p-value was 0.032. And the alpha they gave us was a 5% alpha. So this is 3.2%. So p is smaller. So we do reject the null hypothesis. So that would be my M, my make a decision. My conclusion statement with a p-value of 0.032, at the 5% significance level, we do, and that do is going to match whatever you wrote on M. So if you wrote do reject, you do have evidence. If you wrote do not reject, you write do not have evidence. So we do have sufficient evidence. The mean call time is greater than 3 minutes.